Okay, questions? Which of the following results from the fact that signals propagated by the ionosphere are elliptically polarized? So elliptically polarized just means they're neither perfectly vertical nor perfectly horizontal.
Somewhere in between.
Somewhere in between. Bravo. Either vertically or horizontally can be used. So it just means that your signal might vary, you might hear some fading, but that's where it's at.
The problem, and this was briefly talked about, once you hit the ionosphere and things go elliptical, it's also going to be variable.
Yeah.
So a wholly vertical antenna or a wholly horizontal antenna is irrelevant, because it's going to change anyway.
Yep. Yeah, you never know. And just so you know how much it can vary, the difference between vertical polarization and horizontal can be up to 30 dB.
Yeah,
We're talking
it
about
can be huge,
huge drop in signal strength.
or it can be nearly nothing.
Why do VHF signal strengths sometimes vary greatly when antennas move only a few feet? Multipath propagation cancels or reinforces signals. What weather condition might decrease the range at microwave frequencies? Precipitation. Why? Well, those water droplets are a higher density. And if you have a lot of them at higher density, it's going to slow down the wavefront and it's going to interfere with propagation.
Well, it's not killing altogether.
What's the effect of fog or rain on signals in the 10 meter and 6 meter bands? There's little effect, especially below that, but at 20 meters, there's almost no effect at all. What's the effect of vegetation on UHF and microwave signals? Absorption. When we're talking microwave, like 2.4 gigs, mesh network stuff, you can't have anything in the way. No trees, no foliage, nothing. It's got to be direct line of sight. And fog and stuff will start to affect it. What antenna polarization is normally used for long distance CW and single sideband on VHF and UHF bands? Now, the kicker here is not what's best. It says what antenna polarization is normally used for long distance CW and single sideband contacts. What's the antenna we normally use?
Wire dipole.
Horizontal polarization. Okay? So just really read the question. When using a directional antenna, how might your station be able to communicate with a distant repeater if buildings or obstructions block with a direct line of sight? Find a path that reflects signals to the repeater. Why is the radio horizon for VHF and UHF signals more distant than the visual horizon? That guy on the beach keeps walking until he goes right out of sight. Can't see him anymore. But I can still hear him on our walkie-talkie. Why does that work? The atmosphere refracts radio waves slightly. What's happening? What is the meaning of the term picket fencing? Rapid flutter of mobile signals due to multipath. What's likely the cause of irregular fading of signals propagated by the ionosphere? Delta. Random combining of signals arriving at different paths. It could be also changing polarization, but it's not Faraday rotation. What's the effect of multipath propagation have on data transmissions? Multipath propagation have on data transmissions. Error rates are likely to increase. Which region of the atmosphere can refract or bend HF and VHF radio waves? The ionosphere. What is the FCC Part 97 definition of a beacon? Yeah, I think we got right. It is deep. So, why are simplex UHF signals rarely heard beyond the radio horizon? That is correct. UHF signals are usually not propagated by the ionosphere. What is the characteristic of HF communication compared with communications on VHF and higher frequencies? Long distance ionospheric propagation is far more common on HF. It does happen on VHF, but not very often. What's the characteristic of VHF signals received via auroral reflection? Yes, they are distorted and signal strength varies considerably. Which of the following types of propagation is most commonly associated with occasional strong signals on the 10, 6, and 2 meter bands from beyond the radio horizon? Sporadic E, not backscatter, because it says commonly associated. And B region absorption doesn't make sense, and gray line propagation not on 10, 6, and 2, but especially not on 2. Which of the following effectively allow radio signals to travel beyond obstructions between the transmitting and receiving stations? Talking about the mountain again.
Quantum tunneling.
Knife edge diffraction, the effect of putting a piece of cardboard or whatever up in front of your eyes. What type of propagation is responsible for allowing over the horizon VHF and UHF communications to ranges of approximately 300 miles on a regular basis? Tropospheric ducting. So that approximately 300 miles could be probably decreased quite a bit. In areas of the country where you have less hills, their repeaters are often getting in the way of each other. Usually in the morning when the sun comes up and there's a temperature inversion, you'll have a duct, maybe over 100 miles. We used to get a duct between Austin, Texas and San Antonio. We had 2 repeaters on the 94.94. And we'd be interfering with each other. We finally went to tones so we didn't interfere with each other. But that was a problem for a while because of that stupid duct.
You can get a 2 meter duct to Hawaii.
Oh yeah. What band is best suited for communicating via meteor scatter? 6 meters. Yeah. And that's a compromise. You want an antenna that has kind of a beam pattern, but above 6 meters, at 2 meters, you need a lot stronger ionization to get the signal back. So at 6 meters, you don't need as much ionization. A weak meteor trail still works pretty good. And you can do like a 3, 4, 5 element beam, and it's still reasonable proportions. What's the cause of tropospheric ducting? Delta, temperature inversions in the atmosphere. What is generally the best time for long distance 10 meter band propagation via the F region? The best time
Right before sunset.
from dawn to shortly after sunset. So it's going to happen during the day because 10 meters pretty much closes when the sun goes down. Which of the following bands may provide long distance communication via the ionosphere's F region during the peak of the sunspot cycle? All of them. 6 or 10 meters. Which of the following is typical of the lower frequencies during the summer? Really? The lower, remember, this is lower HF frequencies. What's happening on those lower HF frequencies during the summer? Getting high levels of noise because of thunderstorms. Why should an amateur operator normally avoid transmitting 14.1, 18.11? What's going on those frequencies? A system of propagation beacons are operating on those frequencies. How is a directional antenna pointed when making a long path contact with another station? 180 degrees from the short path heading. What's a characteristic of skywave signals arriving at your location by both short path and long path propagation? You get an echo. What factor affects the MUF, the maximum musical frequency? Correct. All these choices: path, distance, location, time of day, season, solar radiation, ionospheric disturbance. What usually happens to radio waves when frequencies below the MUF and above the lower usable frequency when they are sent into the ionosphere. They're refracted back to Earth. Okay, that's the magic part of the band, where they're not getting absorbed and they're not going straight up to the ionosphere. What's the approximate maximum distance along the Earth's surface normally covered in one hop? So this is the answer they want. 2,500 miles. 1,200 miles is for E-skip. And then what's the approximate maximum for E-skip? Bravo. What happens to HF propagation when the lower usable frequency exceeds the maximum usable frequency? Alpha. If it's exceeding the maximum usable frequency, you're not going to get anything back. It doesn't propagate. Which ionospheric region is closest to the surface of the Earth? The D region, yes. And that's, the dead region. What is meant by the term critical frequency at a given incidence angle?
Alpha.
The highest frequency, which is refracted back to Earth. Why is skip propagation via the F2 region longer than that via the other ionospheric regions? Charlie, because it's highest. It's furthest away, so you get the longest skip. What does the term critical angle mean as applied to radio wave propagation?
Delta.
The highest takeoff angle that will return a radio wave to Earth under specific ionospheric conditions. That's the critical angle. Below that, no problem. One of the problems you have when you're in a valley with mountains around you is that those mountains are often higher than your critical angle. Why is long distance communication on the 40, 60, 80, and 160 meter bands more difficult during the day? The D region absorbs signals at these frequencies during the daylight hours. Not so much on 40 and not so much on 60. On 80, yeah, and especially right around noon, but earlier in the morning and later in the afternoon, you can still get away on 80 pretty good. But it depends on the season too. In the winter, you can get away with that. In the summer, you can. Which ionospheric region is the most absorbent of signals below 10 megahertz during daylight hours? The dead region. D. How does a higher sunspot number affect HF propagation? Alpha. Higher sunspot numbers generally indicate greater probability of good propagation. What's a characteristic of HF scatter? Signals have a fluttering sound. Think of, scattering signals off of the aurora. The aurora is moving, fluctuating. What effect does a sudden ionospheric disturbance have on the daytime ionospheric propagation? This is your SID, caused by a flare. What does it do? It disrupts signals on lower frequencies more than on higher frequencies because it's energizing the D layer. When that D layer saturates, not much gets through. Approximately how long does it take the increased ultraviolet and X-ray radiation from a solar flare to affect radio propagation on Earth? 8 minutes, just like light. Which of the following are the least reliable bands for long-distance communication during periods of low solar activity?
Delta.
15, 12, and 10 meters. What is the solar flux index? That is delta. What is a geomagnetic storm? A temporary disturbance of Earth's geomagnetic field. It's literally, the solar wind is plowing into our magnetic field, and it's distorted. It's moving around. At what point in the solar cycle does the 20-meter band usually support worldwide propagation during daylight hours? At any point.
20 meters is
20-meter band is your go-to band during the daylight hours for propagation. So it doesn't have to be during the summer solstice, it or the maximum or the minimum. How can a geomagnetic storm affect HF propagation? Think of where that energy is coming in. It's coming in at the poles, right? It degrades high latitude HF propagation. How can high geomagnetic activity benefit radio communications?
Oh, no. Oh, my gosh.
It does.
That's correct. I just
So
looked it up.
this can be misleading. What do they mean by high geomagnetic activity? Is that from a solar storm, or is this just from
That's
higher
really,
numbers of sunspots? What causes HF propagation conditions to vary periodically in a 26 or 28 day cycle?
Something to do with the sun.
it's a, yeah, it's true.
It's Charlie.
Sun's rotation of the sun's surface layers around its axis. How long does it take a coronal mass ejection to affect radio propagation on Earth? Delta, 15 hours to several days. What does the K index measure? Remember, that was the first one we went over?
Right. Bravo.
Bravo, short-term stability of the Earth's geomagnetic field. What makes HF scatter signals often sound distorted? Delta, energy is scattered into the skip zone in several different radio wavebands. And what does the A index measure? This is the second one we're getting.
Alpha.
Really?
Charlie.
Charlie, the long-term stability of the Earth's geomagnetic field.
That's me.
How is long-distance radio communication usually affected by the charged particles that reach Earth from the solar coronal holes? Okay,
Wow.
you know it's not Charlie or Delta because ducting
Right.
is an atmospheric thing. It doesn't have anything to do with solar.
Bravo.
And it is Bravo. HF communication is disturbed. Which frequency will have the least attenuation for long-distance skip propagation?
Charlie.
What's attenuation? Less interruption?
Just below the maximum usable frequency.
What in that?
So this
Just
is
below.
because the skip angle is going to be the lowest in order to affect a skip off the ionosphere with the maximum usable frequency.
Think of attenuation as another way of expressing resistance to the flow of something.
Yeah.
So it'd be the least, it'd be the best you wanted, basically.
Yeah, the least attenuation.
Yeah, so it might.
So the strongest
That
signal.
would be the best.
Right.
Yeah. Which of the following is a way to determine current propagation on a desired band from your station? There's a network of automated receiving stations on the internet to see where your transmissions are being received. That's called a whisper network. What usually happens in radio waves with frequencies below the lower usable frequency?
They just don't,
Charlie.
Yep.
They're attenuated by the delayer before reaching their destination. What does LUF stand for? Lowest usable frequency. What does MUF stand for? Bravo, maximum usable frequency for communications.